Okay, welcome back. I hope you had a good weekend. This week we're gonna talk about IP addressing. We're gonna probably spend a couple of weeks on this. So today we'll touch a little bit on what is an IP address. We did a little bit on the Windows side last time. So we're gonna look at how we can configure IP address in Linux. We'll also take a look at IP version 4 subnetting. And then talking about the interfaces that you see for the system, especially when you're troubleshooting the network, right? So when you take a look at Unit 4 notes or Week 4 notes, it starts with talking about TCP/IP, and this is important. So when you look for IT work, a lot of the time they want you to have the skill sets in be able to troubleshoot, right? TCP/IP network. All the networks nowadays are on TCP/IP. So we'll touch back a little bit on the protocol. And as we mentioned when we talked about the OSI layers, IP is purely for addressing. So what we want to take a look at today is how do we set up a subnet with the proper IP addresses. And be able to maybe segregate that part of the network or assign IP addresses using a server. So TCP stands for Transmission Control Protocol, and we know that TCP requires acknowledgement in order to communicate, right, or transmit. And IP following it is a way that we can route data or information packets in and out of the network. So there are two categories in IP, or two types. We have the private IP, which is using internally inside the organization. And we have the public IP, which is assigned, right, for the subscription that we pay to internet service provider. So at your home, your wireless router has a public IP address, and your router uses it's a way that it's a gateway to the public network. So all your devices use that one public IP address. Now, we can use TCP/IP to connect all the systems, including autonomous systems, right? And often you see autonomous system in the larger network across nations and also internationally. You would see them as routers or communication devices. Okay. Now with the IP address, we're going to talk a little bit about the subnet mask. That's kind of like the zip code of your system, right? It narrows down in what segment of the network is communicating. And then the default gateway, that's often the router. Doesn't always have to be, but 99% of the time, it's going to be your router, your edge router. Okay, so let's look at our first question. So we know what really makes up an IP address on page 1 of our notes. We know that an IP address version 4 consists of 32 bits. And that was limiting because eventually the world ran out of IP address in 2011, right? That was a long time ago. But why are we still using it? It's because the network that we have still works, and in order to change all the IP address over, we have to reconfigure our systems, right? So in the larger scheme of things, when you're looking at public IP addresses, a lot of them have transitioned to version 6. So we know that IP version 4 is 32-bit in length. And when you are looking at an IP address, for example, in the question 2 right here, right? You're going to see that there are 4 octets. And it is denoted by, it's separated by a period, right? Or we say dot. So when you're looking at an IP address 192.168.0.100, very similar to your home system IP address, like what you see at home or inside a small wireless network, because wireless router defaulted to 192.168.x.x, right? So each of the decimal value before the period, we call that an octet. It consists of 8 bits. And if you take 8 bits plus another 8 bits, that's 16, plus another 8 bits, right? And so on. So you are going to have 32 bits. So you have 24 plus 8, that's going to be another, that's a total of 32 bits. So we know that our version 4 IP address is 32 bits, whereas version 6 IP address is 128 bits. So we have more combination of addresses in with that particular length. So as you proceed, the more devices that exist in the world, is going to require us to use longer addresses in order to have more combination of addresses to use. So we mentioned that there are 4 octets in version 4, and each of the octet represents the value before the dot. And there are 8 bits per octet. Okay, any questions? So we always refer to version 4 for the private addresses. How? Because a lot of the administrators still manage the systems with version 4. Okay, so before we go into the next question, we're going to come back to the notes here. And this is where you can find the information about the octet and the length. But it's very important that you know that there are specific value that's indicated as a network ID and a host ID, depending on the subnet mask or the class or the classless address. Okay. So a subnet mask really represents kind of like the zip code of a home in the city, right? If I look at Moreno Valley, I would see that there's 92551, there's 92553, there's 92557, there's 92555. There's many zip codes, and that represents a certain portion of the city or town. So the way that we really design our network and system really represent who we are as humans, because logically that's what we see. So your subnet masks really represent what section of the network, what segment, what group, which group of systems are communicating or requesting. So when you look at the next section in following on page 1, you would see that there is an indicator for a network ID. And this is where it's going to narrow down, right, what part of the network that is by using that numerical value. So if we take a look at the example here, if we're using this IP address, right, like something that you would have at home, 192.168.1.15, if we break it down to each of the octet and we look at the subnet mask, so if we're using a classful address, so when I say a classful address, that just represents that we follow the world schematic of what class A would be, class B, and class C. So when we look at this, we know that this is a class C address, if it is a classful address, right? And that means that the subnet mask is 255.255.0. It's a class C. So when you look at a class C, the first 3 octet represent the network ID. So this is how the router is able to determine which switch it would send that to. And the switch would then pass it down to the system that is communicating. Now the host is the last octet, which is 15, and that's unique to that computer. So you cannot have a duplicate address. I cannot have the same address on the 2 systems, right? It's going to generate an error, okay? because it's gonna say, it can't distinguish which one is requesting certain type of packets or data. So when you're looking at an IP address, the first thing that you should ask yourself is, what is its subnet mask? And that's gonna help you determine what part of the network that is and which system that is, okay? All right. So that's really important in looking at just the IP addresses and its subnet mask. Now let's take a look at number 2. We go through each one. So for number 2, it asks you to determine which octet of the IP address is the network ID, right? Given the subnet mask. So the example, the first question is very similar to the example that we saw on the notes. So for A, we have an IP 192.168.0.100. And when we look at the subnet mask, this is a class C address. Okay, whenever that you see 255, that means all the bits are on. The computer, the router, the switch, basically it's a computer. It's really simple, right? Its job is to see how many bits are on in each of the octet that's going to represent that part of the network. So in this case, the first 3 octet, all the bits are on. And so it's going to narrow down that segment. And whenever you see 255, that represents the network ID. So for my IP address, the first 3 octet are the network ID for that system. Okay. Any question? So you're expected to know this for certifications and your quiz and final exam. Now, if we go with more of a common address in an enterprise, and when I was learning networking long ago, right, I always asked my professor or teacher, I would say, why do they use 10, right? So it's just a value that everybody agrees on, right, in class A. But when you take a look at the table for the classes, class A can go from 1 to 126, right? So any value in that for the first octet is going to indicate, right? So how do I know this is a class C and this is a class A? You look at the first octet. If it's higher in a certain range, so I know that class A is going to be from 1 to 126. I ask myself, is this octet higher than 126? Yes, right? And then I look at class B. And we know that we don't use loopback. Loopback is built into the system, so 127, but usually in assigning IP, it will be like 128 to 191, right? So since 192 is higher than class B, it has to fall into class C. We don't use class D and class E addresses. That's for research and government, okay? So on question number 2B, you see that this is a 10.0.0.1. This is often a router IP, right? Router often end with the host ID as 1, because when you're entering from the public network, you find the gateway, and that's the first system that you see. So when we're assigning IP address manually for our routers and switches, we have to logically think about which one is the first, which one is the second, right? So the first edge router that you see is often a .1 for the host ID. So this is a class A IP address, because 10 is between 1 to 126. Okay, you look at the first octet, this value. And that means that it is a classful address with the subnet mask 255.0.0.0. So class A, the first 8-bit is on. Class B, the first 2 8 bits is on, or 16 bits are on. And class C, 24 bits are on, right? We don't use class D and E, okay? So with B, we know that this is a class A. The first 8 bits is on, so that means that the 10 is a network ID for that address. Okay? Is that confusing? Any question? If you're not clear, ask now because it's going to get a little harder. So I'm not going to lie, like when I learned IP addressing, it took me a little bit of try. Like you have to, go back and visualize it and understand the concept to apply this. But sometimes some people, they pick this up very quickly. And everybody explains subnetting a little bit differently. I'm going to teach you how I learned, and I felt like it was an easier way for me, but there are tons of tutorials online that provide you, but the classes stays the same internationally across. It's for the industry. Yes, question.
If it's 255, then it's the network architect is on.
Yeah. So that means it's a network. So the first 255 here, it tells you that the first octet is a network ID. 255 also represent broadcasting, right? So whenever you see all 255s are on, like 255, 255, 255, like all 32 bits are on, that's a broadcast address. That means it sends to all, it doesn't receive. And we talked about that last week. Yeah.
Classes are, just to clarify, classes are divided by like the numbers of the point. So 192 to 248 is class C.
Yes.
So I'm assuming anything with the 10 in front, that's a class A.
Uh-huh.
Okay.
And why do they use 10? It's just because we are, as an industry, we agree to use 10. You can use 11, you can use 12, you can use 80, right? It's just most administrator learn that 10 is a common way to start that octet. So when you go into like a network like this, you see 10. Yes.
Common practice for private IP.
Yes. So class A gives you the most addresses. Okay. So if you have many computers, right? The variation in that is you have more combinations in class A with class A addresses if you have a lot of hosts. So if I have bring your own devices, a lot of employees, a lot of offices, my network has a lot of systems, I would use class A IP address. Class B is a little bit less. So if you have more host address, right, then you would have, because look at it, right? If you're looking at a class A, you have 24 bits to play with for the host. If you take 2 to the power of 24, you have the math for how many hosts you can have. Understand? Because why is it 2? Because it's binary, 0 and 1s, right? So when I look at the variation, if I'm looking at class C, it's for the smallest network. Why? Because I only have 8 bits. So if you take 2 to the power of 8, that's the maximum number of system you can have on that network. Okay? So 8 bits, just the host here just represent the 8 bits. So we take 2 and raise it to the power, and we would see. Now class B, how much? Right? How many system? Well, 16. 2 to the power of 16 is going to give you the total maximum number of computer system switches, all of the devices that needs IP addresses connecting. So for C, we look at the first octet, 172 falls in the range for B. And so you would say that this is a B classful IP address. That means it's 255.255.0.0. So the first 2 octet is the network ID. Okay, before you learn subnetting, you need to distinguish between which one is the network ID and which one is the host. The easiest way is to look at its subnet mask. Now, these are classful addresses. Think of them, they're like traditional addresses, right? Eventually, we kind of ran out and we started borrowing into some of the octet, and we'll talk about subnetting in a little bit, okay?
All right. So we see another 10, right, in the front. So we know that's a class A. But wait, you said, Dr. Wen, you told me 255, but this one is 254. So when you see something like this or another value, 252, etc., right? It's borrowing bits into another octet. So this is not a classful IP. So, but look, because this kind of looked like a class B, but the first octet is a class A. You see what I mean? So it leans into another class. This is a way that we can manipulate IP addresses so we can have a higher range. Let's say that I have an IP address that I use for most of my network, right? I have that octet. And then eventually I add more device and I started running out. So the way that I can do that is to keep the IP address the same, but to play with the subnet mask and change it. And this is what we call subnetting. Okay. So this is not a classful IP address. Why? Because if you look at the subnet mask, it's not like the traditional subnet mask, the classful subnet mask up here. It's 254. And we'll see how that number is derived, right? Okay. So that means that when you look at the subnet mask, it falls into class B area. So that means that the first two octet is your network ID. So the 255, 254, the value indicate the bits are on is important. Okay, question. All right. So we'll see something similar for quiz and exam. Here it talks about default gateway. I think I explained that a bit. And usually you see that as a router. It can also be a server or a computer. Okay. Sorry. Let's go to the next question. If computer A is sending data to computer B, how does computer A locate computer B in the network? And I want to break this down to the most simplest concept so that way when you're looking at how the IP address works, how it's able to locate it, then you would know. Computer A uses a subnet mask to determine computer B is on the same network by comparing the network ID. Because the network ID really relates back to the subnet mask. That's how it's able to know. It's kind of like you ask your friend, hey, what's your zip code, right? And they would say 92620, and you're like, oh, you're definitely not from IE, for sure, because you know that that zip code is not in this local area. But if that person says 92553, you say, oh, okay, you're in Moreno Valley. So it uses the subnet mask to really determine whether the other system is on the same network or not. If it's not on the same network, then what happens? It needs to be routed, right? So if I have a system, for example, using a wireless network, having this IP address, and it's talking to another system using this IP address, guess what happened? They both need to be routed. So if I'm sending from A to B, right, my data from the A needs to be routed out of that network into the B network. And the routers to router needs to have, the communication needs to be established there. So the router A, right, is gonna route the data to the router B, then it's gonna send it to the system B. And then from the system B, it's gonna route back, okay? So whenever that you see different network ID, definitely not in the same town. And when you're not in the same town, it needs to be routed. Okay? Any questions? Okay. So that leads us to the next question. To send data in the same network, what configuration is needed on the sending and the receiving system? You need to have an IP address because everybody is on TCP IP networks. And you need to have a subnet mask. It's like when you're sending a package, right? You need to have an actual receiving address so that way that package can go to the right person, the right house. And the zip code for that address. So the IP address and the subnet mask. Whether you manually input that in or you are automatically assigned from the system, from the server. So if I have 10,000 computers, I don't want to go through and manually inputting every IP address. I would use dynamic host control protocol system to be able to assign addresses automatically. And this is a role that your wireless router use or take on. So when let's say that I buy a new tablet, I open it, I turn it on, and I add it to that wireless network, automatically in the back, the server is gonna see that tablet that I'm trying to connect, right, with SSID and passcode, then it's gonna automatically assign the IP address because out of the box, your wireless router at home does that, right? So next week, you're gonna configure DHCP. I wanna send you off in this class knowing everything that you need, at least at foundational level, to be a network technician or even an administrator, okay? So we will configure all the server roles for most of this class. So whenever we talk about it, we're gonna do that. So we'll do that next week. Or if we need to spend a little bit more time on IP, we can carry it on to the next week, the following week. Any question? Okay, question 5, it says, what configuration is needed for a system communicate with the internet or another network, right? So I mentioned this when we talked about computer A and B with different IP addresses earlier. You, of course, always have an IP address. You need its subnet mask, and because it's one network to another, you need the router IP address, the default gateway. Okay. And then we'll come back to route and how to set up manual routes for destination and so on. Okay, any question regarding network systems within and outside of the network? Okay, so we will be doing a little bit of binary conversion today. Some of this might be new to some of you, and then some of it is like review for many of you. It's fine. You know, we have to see what the computers see first in order to understand how it works, right? Okay, so let me move these down in case someone's still recording the answer. Let's bring this up a little bit. All right. So let's go through and understand different number systems. I do this with my computer science students because I said you cannot be in computer science not knowing the number system. And discrete structure is really aimed for that, CIS7 specifically for computer science, right? And then they do low-level programming, which is CIS11. So they have to understand binary. So it's really important. You have to understand what these numbers really mean and how the routers or the system sees these values. We, human, use decimal number. It's a base 10. Your counting number, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Repeat, right? It's an increment of 10. That's a decimal value. Okay. So when you're looking at an IP address that's version 4, it uses decimal number in the octet. Now, if you're looking at version 6, it uses hexadecimal, which is a 16 base value, right? And that goes from 0 through 9 and then A through F. There's 16 numbers. But ultimately, all of these things break down to binary, 0 and 1s, right? The computer is a complex calculator. It still is, right? I don't care what people say about, oh, I'm gaming 3D. Well, it's still calculating all of that numerically. Okay. So that means what? We need to understand what it sees. So let's say that I have 172 and this is a base 10. So I know when you see the little number at the base like this, it tells you that's the number system that you're using. That's a decimal value. And I want to convert this into binary to see what the computer see as a value for 172. Imagine you type 172 or punch that into your calculator on your Windows system, right? The computer quickly convert that to 0 and 1s, and this is what it does. So there are several ways to do this. Some people do it divide, right, by division. Some people do it by subtraction, but ultimately, you know, when I teach computer science, I said division is subtraction multiple times and multiplication is addition multiple times. So when you look at this value, okay, you would start with a scale, and this scale stays the same no matter what. It's 2 to the power of n, it's multiple of 2. You start with the least significant bit on the right-hand side. It's always on the right-hand side. It's gonna go left and it's gonna increase. So when you're looking at the first bit, it has the least significant value, which is 1. Okay, that's 2 to the power of 0, which is 1. Anything to the exponent 0 is a 1. Like 500 to exponent 0 is still a 1, right? So 2 to the power of 0 is a 1. Then I go to the next bit. You're going to multiply it by 2. 2 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, 128, and it continues. But I only want to look at the first 8-bit because it fits this. Okay? Then you're going to look at the scale and you're going to ask yourself, what's the highest number that I can subtract from on the scale? These right here. So I have 172. What can I subtract? 128, right? So I take 172, subtract 128. When I subtract it, I put a 1 in that, on that bit slot, so it turns on. Okay? So 172, subtract 128, that turns on. We got that? Any questions? It's kind of like you have $172. You go down the aisles, you say, what can I buy of value in this aisle? And the highest thing that you can buy is it's cost $128. Then you're left with $44. Then you go down the aisles again and you subtract. Well, 44 is less than 64. I cannot afford that. So put a 0. That bit is off. But 44, I can subtract 32 from it. So when you subtract, you put a 1. So 44 subtract 32. I have 12 remain. Then 12 subtract 8, because I cannot subtract 16. It's less than 16, so that bit is off. I can only subtract things that are smaller, right? We don't want to go negative. So there's no negative value in the system, in the computer. It's actually a sign value. Negative is, that negative sign is for human. Right, that's another discussion, but. So after I subtract 32, I'm left with 12, and 12 is less than 16, so I cannot subtract, so I put a 0. That bit is off. Then I take 12, I look at the next value, that's 8. So 12 minus 8, I have 4 left. So when I subtract it, I put a 1. That bit is on. And then, so I have 4 remain after the third step. I look at what's left, 4, 2, and 1. So 4, subtract 4, perfect. When I subtract it, I put a 1 and I'm left with 0. Now, when there's no remainder, the last 2 bits are off after I subtract the 4. When you divide it by 2, you just divide it, you keep dividing, but when you write the number, it's going to be from bottom up. So that means that 172 in decimal value is equivalent to 10101100. So today, when you type in the IP address 172.168, right, .12.x, well, the first octet is that binary. Okay, and then you can do a 10. 10 is really quick. It's 8 and 2, right? So the rest are 0. So 0, 0, 0, 0, 1, 0, 1, 0. So I put that chart for you so you can fill that out, so you can see, and from my experience that helped the students. But if you don't need it, you can just type it out. That's fine. I'm not picky about the answer. So how can I check my answer? You're gonna ask me, well, I don't have time to do this all the time. I can't calculate all the IP. Well, there's IP calculator and there's programmer calculator. So on your computer, if you open up your calculator, and on the Mac there is, I think you have to turn on the mode or whatever, but so this is a regular calculator that you get from your OS, right? Normally it shows up with scientific mode. If you click the navigation bar, the three lines up here, and then you put it on programmer mode, right? You see that there are different number systems. There's bin for binary, oct for octal, 0 through 7, DEC for decimal, that's human value, right, number, and hex for hexadecimal, that's a base 16. Hi. So I want to check, right? My question was 172. I want to make sure my answer is correct. So you select decimal and you type in 172. And you click on bin for binary. And there you go, right? That's correct, right? So now you know how to use. Now for the exam, right? I use lockdown, and lockdown doesn't. I will give you a calculator, but it doesn't have a programmer mode. So you can use scratch paper to figure this out. But it's really simple. So the first step is to put down the scale. It's multiple of 2. Start with 1. 1 times 2 is 2. 2 times 2 is 4, and so on until you get the 8-bit. Second step, look at your decimal value. If you're converting from decimal to binary, go through your decimal scale, see what you can subtract from. If you can subtract it, put a 1. If you can't, put a 0. And there you have it. Okay? All right, let's do another one. Number 7, convert 255 decimal value to binary using the below table. Okay? So your scale stays the same. It's multiple of 2. So you start with the given value, 255. I look at the scale and I said, what can I subtract from the scale? And you ask me, why can't I go further to the 9th bit, right? Well, if you have 2 to the 9th power, you get 256. So it's too big. You can't subtract. Okay, 255 fits into the 8-bit. So you take 255, go down your scale, see what you can subtract. And I can subtract 128. So I put a 1 there. I'm left with 127. Then I go down the scale and what can I subtract? The next number I can subtract is 64 on that scale. So 127 subtract 64. When I subtract, I put a 1 and I do the math. I'm left with 63. 63, I look down the scale. Oh, 32 is less, so I can subtract it. So I take 63 minus 32. When I subtract, I put a 1 on that table. I'm left with 31. And I continue. 31 subtract 16. That's the next number. When I subtract, I put a 1 and I'm left with 15. And here you can quickly go through. You're like, oh, I can do this. So earlier I told you that when you have 255, all the bits are on. It is. You prove it here, right? So 15, I can subtract the 8 because that's the next number. So I put a 1 and I'm left with 7. 7, I look here. 4 is the next number. Yes, I can subtract it. So 7 minus 4. When I subtract it, I put a 1 underneath it. And I'm left with 3. Then I have 3. The next number is 2. So 3. Yes, I can subtract the 2. So 3 minus 2. I put a 1 right there. And then I'm left with 1. Then I have 1, subtract 1. And now I have nothing left. So when you have a 255 in the subnet value, right, you see that all the bits are on. Now, when you look at this, you're like, oh, what if it's 254? Well, it means that from the second to the 8th bit that's on, the only one that's off is the least significant bit on the right. That gives you 254. Okay. So when you start seeing this, you're like, oh, well, I can see now how, 100 and 192, how that would work, right? Okay. So I'm going to repeat the step again, right? Practical step. Put down the scale for decimal equivalent, which is multiple of 2, starting with 1. 1 times 2 is 2, and so on, right? Then you look at the value that you can subtract at the highest, and you start with that. And if you subtract, you put a 1 for that bit. Then the remainder, you take that remainder and you keep subtracting down that scale. If you cannot subtract it, you put a 0. If you can, put a 1 for that bit or that placement of the bit. And then when you're done, you write it out. So I have all 8 bits on for 255. And that's your answer. And then you can check with the calculator. Are we okay with this? Any questions? Piece of cake, right? Not too hard. Just binary math. You guys are pretty lucky. This is probably the most extent that you need for IP addressing, which is decimal to binary and maybe hexadecimal down the line, but we don't really have system that use octal value anymore, so learning it is probably good to I do that lecture in the other CIS classes because they have to understand octal, hexadecimal, and then we do the binary map. Like addition, subtraction, division with binary. Okay. So for quiz and final exam, right, we're expected to know how to do conversion, like I said. You'll be given binary value or decimal value and you have to convert. Okay. I just want to make sure when you see that octal or that octet, that value in the octet, you would know how that is equivalent in binary. And we can always use the calculator to check, but it's important to know the concept. Any question? Okay, can we move on to the next one? We're okay with this? If you're not clear, if you don't want to ask now, you can always see me after or during office hours. Okay, now you can try number 8. You're given 127, you see this in the octet for loop back, right? And we want to convert 127, which is a decimal value, to binary. That should be easy. Well, you know it cannot be 128 because it's less, so 0 goes there, right? And I take 127, go down my scale, I know that I can subtract 64. So I put a 1 there. 127 minus 64, I'm left with 63. Then the remainder is 63. I go to the next number on the scale, which is 32. 63 minus 32, I put a 1 there. And I'm left with 31. Go to the next number, which is 16. So can I subtract 16 from 31? Sure. So 31 minus 16, I'm left with 15. So if I subtract, I put a 1. And 15 is my remainder. I go down and I know that 15 is larger than 8. So I can subtract 8 from it. So 15 minus 8 leaves me 7. So put a 1 there. Then I go down the scale again. 7, subtract the next number. Yes. So 7 minus 4. Put a 1 and I'm left with 3. And then I go down the scale again. 3 minus 2. I'm left with a 1. And when I subtract, I put a 1 beneath it for that bit. And since I have 1 as a remainder, I have to keep going until there's nothing left, right? So 1, I go down the scale. The last one is 1. So 1 minus 1 is 0. So when you see the loopback address 127.0.0.1, right? You know that all the other bits are on except for the 8th bit. Okay. And there it is. So the communication system, the network systems, it's really looking at the bits, right? Which bits are on and, you know, out of that byte, which is the 8 bits. So if it sees that in this byte, right, from bit 1 to bit 7 is on, except for bit 8 is off, then it knows it's a 127. To us, to human, we sees it as a 127, but the computer, it only cares about which bits are on and off. That's it. So when we write the IP address, it's really for us, right? But the computer, it converts it to 0 and 1s like this. Any question? So I try to use the common value that you see in a lot of the IP addresses. So you can relate when you look at the octal or your IP address today, when you put that in, right? You think to yourself, oh, how does the computer sees this? Okay. So now we're gonna go in reverse. We're gonna go from a binary to a decimal value. We need to know this so that way we can do subnetting. Okay, this is gonna apply to the later part. Any question regarding 8? Okay, so let's say that you're given a binary value, which is number 9. We have 11111000. And you need to make this into a decimal value, right? Sometime when you see this, you automatically know it's 0 and 1, so it's binary. But sometime they would put a little small base number, which is a 2. So if you want, you know, a lot of the textbook does that, but we don't need to really have to add it. So if you want to add the base, you would click this button on Microsoft Word like this, and then you can add a 2. So if you see a little base number like this, it just tells you it's a type of number system that you're working with. And this is a base 2. That means that there's only 2 numbers, right? 0 or 1. Okay. So you start with the same scale. But instead of subtraction, when you go from decimal to binary, we subtract. But when you're going from binary to decimal, we add. Okay? So what you do is you start with the same scale that's multiple of 2, starting from the right, which is 1. Then you put the binary value into that scale. Okay, you put it for all the placement of the bits. And then whichever has the 1s, you're going to add them up. Again, use the same scale, which is multiple of 2. Take the binary value and put it into that scale. And if you want to start from the right, I normally do, that's fine. But we're taught to write things from left to right, so you can do that too, right? Just be careful when it's less than 8 bits, right? Just gotta make sure that it starts with the right-hand side, okay? So after I have put the binary into my scale, I would look at which bit has the 1 and the decimal equivalent for it. I'm going to add it up. See how I highlighted? So bit 4, 5, 6, 7, and 8, those are on. So I would take the decimal equivalent value, starting with an 8, and I add that up to the next one, which is 16. So 8 plus 16 plus 32, because bit 6 is also on. And then plus 64, that one is also on. And 128. And so once you add them all up, you can use your calculator, right? Just switch it over to scientific mode if you want, or you can use the decimal and then add. You should have 248. And we would put the base 10, and the button for that is up here, if you want, right? So the decimal value for this binary is 248. So when you go from binary to decimal, you add up all the decimal, the equivalent value for the bits are on, and when you have the total, that will be your decimal value. Any question? And you can try 10 if you're working ahead. So again, when we look at number 10, we're given this binary value. And if you start, it's starting to gel already, right? You say 1, 2, 4, add those up and you have it, right? How? Well, you start with the same scale, multiple of 2 from right to left, starting with 1. And then you place the binary value underneath that scale. Right? I always start with the right. So if it's a shorter value, I don't mess up. So 1, 1, 1, and the rest are 0 in the front here. So the only 3 bits that are on is bit 1, bit 2, and bit 3. That gives you a 7. Why is it a 7? Well, the decimal equivalent for this bits that are on is 1 plus 2 plus 4. So I have a 7. And then when you look at 11, it should come to you now, right? Same scale, 128 plus 1 is 129. Done. And so it gets easier, and then eventually when you're looking at the CIDR, you're like, oh, CIDR just indicate how many bits are on, like the /16/8/ you know, 12/ that's just to indicate how many bits are on. Okay, so for the next one, same thing. We start with the same scale, multiple of 2, 1 times 2, 2 times 2, 4 times 2 for our byte or 8 bits. Then we place the binary value for each of those bits for our byte here. And then we look at which bits are on. So my first bit, which is, that's on, the least significant bit, your LSB. And my most significant bit in a byte, which is bit 8. So 1 is the decimal equivalent for the least significant bit. 128 is the decimal equivalent for the most significant bit. So 1 plus 128 gives you 129. Very simple. I'm a very visual person, so when I highlight things like this, it also helps me, right? So that way I can track things. But however you want to learn and whatever that's easier for you, some technique, like some people, they prefer to use division for decimal to binary and then multiplication for binary to decimal. It's very similar, right? But I just feel that a subtraction and addition is easy. So, but there are different ways, different approach. Question. All right, so I'll leave this on for a few seconds here and then we'll switch over to classes now. Because earlier I opened with which one is which class, right? So now we're gonna go back and we're gonna come back to that. We'll talk about the class a little bit more. Okay. So I put down all the information, all the example, very similar to what we've done. So if you need to refer to the notes, I put down the steps and I even put the arrows and how you can add those up. So just remember, when we go from decimal to binary, we subtract. When we go from binary to decimal, we add, right? Same scale, 2 to the power of n or multiple of 2 starting with 1, which is 2 to the 0. Now let's talk about IP address class, because earlier you looked at me like, what is she talking about? Right, here it is. When you're looking at a classful address, class A, like 10.0.0.1, the first octet falls into this range, between 1 and 126. That's all you need, right? 10 is between 1 and 126. So if it is a classful address, it is a class A. And class A has network, which is 255, and the hosts are zeros. Okay? So that means that it is approximately, rounding off, 16 million hosts. So when you're looking at an enterprise network, the majority of the time, 99.9% of the time, they use class A because it gives you the most computer on that network, the most connected hosts. So how do I calculate the host? Well, 8 bits plus 8 bit plus 8 bit, which is 24. And I take 2, raise it to the power of 24, I get 16 million. And how many networks I can have? So earlier we talked about, we can isolate the network by giving certain number. What if I have 11 dot or 12 dot or 10 dot, right? I can have up to 2 to the power of 8 networks in that enterprise using class A. So if you have less network, you're going to have more hosts, and that is class A. For class B, that's going to be 128 to 191, the first octet. That's all you need to remember, right? That's going to give you 65,000 computer tablets, whatever, right? The hosts, and 16,000 network. So it's kind of like in the mid-range, but it's still a lot of hosts. And your subnet mask, network, hosts, right? So it's 2 to the 16 for both sides, half and half. And then class C, which is your home network, 192 is the first octet, up to 223. I do see administrator now using like 221 or, so for class C, that's for small business and home use. You tend to see that because you can have only up to 254 systems. Right? So if you're already at 100 something, there's a bottleneck issue already at home, but I don't think we reached that yet. But in a small business, let's say that if I have a home business and I have a lot of systems connecting, right? I can have up to 254 systems connecting. But I can have up to 2 million small little networks with class C, right? 2 to the I have this backwards. Sorry, let me fix that. That's an error. So this should be an 8. And then this should be 24. Because mathematically that doesn't. Okay. And then class D, that's reserved and it's for multicast group. And class E, this is for research and development purposes. So you don't really see D and E in the regular networks. So when we're looking at an example, let's say if Google address is 216.58.216.164, you just look at the first octet, which is 216, you ask yourself, which range? Well, that's a class C. But important, if it's not a classful address, you have to look at the subnet mask as well. Because they can tweak the subnet mask even though it looks like a class C. But if the subnet mask is 255.0.0.0, it's a class A, then, you know, that's not a classful address. It's not your traditional IP address. Okay. So if it is a classful address, it falls under C. Right? 216 is between 192 and 223. Okay, let's answer the next question. Oops, sorry. Given IP version 4 address 10.0.0.101 and the subnet mask is 255.0.0.0, which class of IP version 4 address does the given IP address belong to? So all you have to do is look at the octet. Sorry, cursor. And since this is your subnet mask is a classful, right? We know that this is 10. You look back in your notes. 10 is between 1 and 126. So that's a class A. Then for 13, locate your IP address from your computer on the home network and determine, or you can use the computer here. So how do I do that, right? Let's do that right now. You can go into your search bar for Windows and you type in CMD or command prompt, CMD. And you are going to just open up the app. So you click it or press enter. And then you're going to do IP config. Type IP config. We learned last week on how to look at it, but sometimes you cannot access settings as a regular user, but you can definitely find it this way. Type IP config, right? Remember what last time I talked about space/all gives you everything. You can do IP config and press enter. And my IP address, sorry. My IP address is 10.111.83.131, right? You said, okay, well, this octet 10, that's a class A, but look at the subnet mask. It is not a classful address. It is a class C subnet mask because there's network ID, and network ID, and this, they subnet here. Okay. When you see this, right, you say, which class is this? This is a class A, but the subnet mask doesn't show class A. So it is a classless address. Okay. Yours might look a slightly different because I'm on the wireless network, but it could be on the same segment. But anyway, so I did this from my home system. And when I looked it up, it was 192.168.0.23. Or if I want to use the one at school, it would be like this. So this one at the top is my home. I'll type that out so you can see. And it's a class C address, right? And my subnet mask is 255.255.0. But for our CCD, we say school. This is the IP address. I looked this up last time. It's a little different today, right? But it's 10.111.90.11. Well, it's a class A IP, but the subnet mask shows a class C. This is a classless IP address. And the top one is a classful IP address. Because it follows the standard for the class for my home IP, and the school, it doesn't follow the standard class subnet mask, so it becomes a classless IP address. Okay, so that's like an example for you to follow. And you just do IP config. In the command prompt to see your IP. And it should pop up this, right? So this is the school one now. And it's still a class C, classless IP address. Okay. 14. Given an IP address 172.10.0.80 with the subnet mask 255.255.0.0, which class does it belong to? Well, we look at the IP octet, that's a class B. We look at the subnet mask, it is a classful class B, right? Standard. So it is a class B IP. So you can look at the table in the notes, look at your octet, look at your subnet mask. So this is what I've been trying to relay to you for the last, I guess, 15 minutes. Look at the first octet, look at your subnet mask, right? If it is a classful, it follow the standard class, then you put down the class. If it's classless, if it falls into another class, you put down that class. And then for 15, we don't use class D and class E IP address because D is reserved for multicast group. So multicast is sending to all the system in that group. And class E is reserved for research. So entity like IEEE, they do a lot of research based in communications, electronic communications systems, computing systems, right? You see that they might do some pilot with devices in that range of IP. It's specifically reserved for that. So the usable IP address is only gonna fall into A, B, or C for private IP. We had public IP for version 4 and that already maxed out. Any question regarding classes? Okay, so let's go through. And I want to talk about network and broadcast address before we learn subnetting. So after the notes section for the classes, you will find additional information, right? I put down, look at the octet, the first octet, and the default subnet mask. The loopback address, we use this to check if our system itself is connected, right? We touched a little bit on this last time. So loopback address is always 127.0.0.1. It replaces the regular IP address, yes, you can use the system IP, actual IP address, but this is the way that it sends back to itself to see if it's connected or it sees itself as a system that's connected. Okay, so there are some illegal IP addresses that cannot be assigned on the network. Things with the host ID that ends with the 0 or 255, we do not assign. That's not used. It's used for network, and 255 is used for broadcast. So for each of your segment or the group of IP addresses that you use, right, your subnet, there are two IP addresses that are often reserved. One is for the network and one is for the broadcast. Those two. So let's say that I have 1,200 IP addresses, right, for that group, but it's less. You got to subtract some of the IP addresses from that group because they are used for broadcast and network. It is a way for the network system to detect which network and how it's able to send messages to all the system on the network. Okay, so we can't use something like this. So when you're trying to manually input the IP with a .0, no, right? We don't do that. Things that end with 255, like let's say I want to assign my printer an IP address, my shared printer on the network, we don't use the host ID with 0 or 255. Okay? And we cannot have a duplicate IP address. Usually when you see this, it will tell you that it is a duplicate. Okay, let's go through and look at which is legal, which is not legal. 16A cannot be assigned illegal network address. Why? Because this. .0 host ID at the end. When you see a .0, you know that it is a network host ID. That is often used by routers. So when you configure router, you would say, okay, this router is for this network. You can use it on router configuration, but never to a unique system, computer, desktop, tablet, laptop, no. Printer, right? Servers, no. And router itself, I said to use a .1, but when you set up the routes, sometimes you would have to say this is the network route, right? But the router, to clarify, the router IP is never .0, right? But to set the route on the route table, you can use the network address, but the router IP is usually a .1 or whichever that you want to give it. For 16B, it's illegal because of the 255 for the host ID here. Cannot be assigned. It is a broadcast address. And then C, 127.0.0.1, we just went over this. This cannot be assigned. Automatically, the system would have this IP. You see it in a little bit when you look at Kali Linux. It is a loopback address. By default, all systems use this IP as a loopback. I call it the boomerang address or how it sees itself. So we don't manually assign this IP to any system. It already has it. Okay. For D, yes, we can use this. 172.0.1.1, it can be assigned. Why? Well, there's proper host ID and network ID. So the octet is not zero, the last octet is not 0 to 55, and the first octet is not in the forbidden value, like loopback or D or E. Then 16E, yes, right? First octet is in the range of our class, and then also the host ID is not 0 to 55, so yes, it can be assigned. Two 24.0.12.1, no, why? Because the first octet falls into class D, as in David. So that's not a usable class. Question 16G, right? Also, the first octet, when you see the higher value, you would see that it's in the upper classes, D and E. So that's forbidden, right? It's reserved address class. So because of the first octet. And then H, 182.3.116.7, it's good. The first octet's okay, it's in usable class. And the unique host ID is not 0 and 255, so yes, we can assign it. Any question? So we need to make sure we know which IP address version 4 can be used, right? Because you might become a network engineer one day, and you have to come up with IP addresses for, let's say, new branches in Southern California or new region, right? The company expanded, and so you have to add on that segment to your existing. So you have to subnet and be able to set up the network for that area. And then this is useful in security. Why? Because we look at systems that talk to other systems as groups, right? Like multicast, broadcast, and then also when you're tracing someone, you have to enter from outside of the network in, because that's how you track. Or follow them all the way deep into the internal network. So network configuration is really helpful for security defense overall. Okay. 17, which is the next part of the note. The difference between private and IP address. So think of private is everything that's inside your home. The public cannot see, right? I can decorate my home however I want. So inside your network, you can use any IP address that's suitable for your network, that scale to your network. So let's say that I have a very large company. I can use a certain class. I can use a certain IP address. I can subnet. I can add, subtract IP however I need to, because that's my private IP. The world does not see that IP. So private IP addresses are not routable within, right? You have to use a router to route it. So if you're using it on local area network, you have to use a thing called network address translation, which you currently use at home through your router. So if I have a game console, a couple gaming computers, a laptop, a tablet for my kid, smart TV, etc., all of those devices use an private IP addresses 192.168.0.x. And when it leaves my network, let's say that my brother is downloading some kind of video on his computer, right? it uses the router public IP, so everybody on that network uses NAT, network address translation, to route it into the public IP. So it takes on only one public IP. Everybody is grouped into that one public IP and be able to get it routed. So your public IP is assigned or given to you by your internet service provider, which is used in the wide area network or in their network, okay? In the larger networks, in the cloud, right? People say the cloud, the internet. It's usually just cluster of networks combined. So who knows how I can find my public IP? Anybody know? How can I find my public IP? When I type in ipconfig, it gives me the private IP of my system, okay? Inside my network. But how can I see what the world sees? Yes.
Your default gateway?
You can go through your default gateway, but your default gateway, if you look into your router configuration, it doesn't really say it, right? So your internet service provider assigned an IP address to that device, to your router. Now, on the industrial router or enterprises router, you might be able to find it on some configuration level through websites. You guys ever Google, what is my public IP? Ask AI. It will take you to several websites, usually provided by internet service provider. And, you know, you can also use Whois. Now, sometimes they block that, right? We use Whois a lot in security to look at, like, you know, networks that are public. And companies like Facebook, Instagram, in some cases, Google, they hide some of that because it gives you all the registration information for their domains. Okay. That's a different discussion in its own. But public IP information, you can find it because internet service provider have to register their IP addresses that is assigned to a certain system. So that way we don't have a duplicate public IP address. Okay. Understand earlier we talked about multicast group in class class D. So what's the difference between multicast and multicast and broadcast? Broadcast is sending data to every system on the network, all the systems. Where multicast sends data to a selected group within the network. So I'm gonna give you an example, right? It re-image computers for upgrades, right? So for example, going from summer to fall, the IT team here has to refresh all the systems, re-image the computer. Sometimes we would install new applications for students to use, let's say in the library. I don't want to broadcast the image from the library to the rest of the network because different system in different locations uses different things, right? Different applications. So what I can do is I can multicast that. And we image it from the network, right? We don't go from computer to computer. So when I was a service technician, that's what we did. I pop a CD in, I reboot it, and it install all the things, the image on there. Or sometimes I would use Norton Ghost. That's like a traditional system application that we would use to image things. So I would set up like real estate office, you know, training center in the mall, etc. that way. And throughout my time, later on, we connect everybody onto a segment of the network through a switch and sends the image to all the computer on that switch, which is great. Because then I don't have to manually do it as long as I have the proper bandwidth to do that, right? So you can use multicast as a selected group to be able to image system, to be able to send messages or error messages to a group of system or whatever that the need would be compared to broadcast where it sends to all the systems. And our network does that. There's certain things that broadcast. What at home broadcast? You guys know? Is your router broadcasting? Yes, it does. It beacons SSID, right? No matter who you are, when you turn on your wireless setting, what do you see? SSID popping up everywhere because it sends to everybody. Who cares whether they receive it or not, right? So if I turn off my beaconing for SSID, it doesn't broadcast anymore, right? But I can do that with the multicast. So that's a thing that I work with some hospital with on HIPAA compliant, right? Certain segment of the wireless network, for example, when the nurses and the doctor use, it shouldn't broadcast because that's an audit item. If you go into certain section of the hospital, your wireless signal doesn't work, right? Because they have X-ray machine and different things, MRI machines that's used that uses a frequency that's gonna jeopardize the wireless network. So we have to design a way where, you know, signal is not interfering, but yet at the same time, we still have throughput on some segment of the network. And then we want to secure patient files where, you know, not everybody can connect to that wireless network. And if they do, it has to be encrypted and all of those things. Otherwise, it's $25,000 per file. So that's money lost. Okay, so now let's go through. You did the earlier one, this one should be a piece of cake. Which one is the broadcast address? Anything that ends with 255 for unique host ID. So the last octet, if it ends at 255, so that's going to be your A, not B, because this one is a .1. That's probably the router or a system that has a valid IP address. Is this hello? C, that's a broadcast. D, that's a broadcast. Sometimes you see this as 252 or 254. As long as that's the last IP address in that subnet, okay? So don't be fooled. A lot of times it's 255, but it could be 254 as long as that IP address is the last in its subnet. It's the beginning and the last we don't use. That's reserved for network and broadcast, always. So -2. And you see why when we do the subnetting. Okay, any question? So hopefully with this foundation, it gets a little bit easier when we do the workbook next time. Okay. Okay, so let's talk about dynamic ports. So ports are just logical connection point to, it could be for hardware, it could be for software to be able to have some form of communication between components or entity. So when we're looking at communication and connection, like earlier when we talk about protocol, a port can be given a value, and whenever we use that service, that value is then being called on or used. Like port 80 for HTTP, 443 for HTTPS. So, and you know that a lot of the service is being utilized by application, like your browser. So when I open up my Chrome or my Firefox and I type in HTTPS, right? Let's say bankofamerica.com. Well, that is when I get to bankofamerica.com, because HTTPS is a protocol, it uses port 443. And 443 uses encryption to have secure connection. So application that you see a lot of time uses services that require ports. And in dynamic ports, this is used for application to run services, okay? So application would use dynamic ports as temporary ports to execute tasks that would relate to services like encryption, right? So when you authenticate to pay your bill or transfer your money or whatever it is that you do on the application, it uses services, and dynamic ports allow it to use a temporary port for that service at a time, instead of having a dedicated port like port 443. So sometime that you would see a port range, and we often in administration, we would use a higher range, like 5,000 to 6,000 in that port range for specific application. And so when you use security scanning tool, and when you're, so let's say I build a reverse proxy, or I'm scanning, what kind of application they're running, what kind of communication is used by that application or that web server, right? I do see some port popping up, and if it's in the higher range, that a lot of the times when it's grouped, it's dynamic ports. So basically, it's just a set of values that's used for specific services for the application, like database, that's tied to a web server, etc. Okay. So whenever you see applications, and we use application for everything, software gotta control hardware, right? So you would see that there are services that's tied within it. And if it needs to utilize communication, definitely. A lot of times it uses dynamic ports. One thing I didn't mention was the APIPA address. This one comes with the system. And a lot of times, like the beginning students that learn networking, sometimes they get confused with the actual address with this. So when you do IP config and you see 169, it's not a real address. It's just an address that's integrated into the system, because all system needs to have some form of address, right? It's not a private address. It's there just for the system's sake. Think of it that way. So all operating systems support a APIPA address. This is a way that we would have some kind of standard out of the box address without having a private IP address. But this address does not allow communication. You will not have network connection or internet connection. So in order to have internet connection in your home, you have to connect to your home network. So you should have a private IP address from your home network. So whenever you do IP config and this pop up, there's a misconfiguration in your network somehow. Either on your network interface card, it's not talking to the network, or on the other side, like maybe the router, the wireless router is down and it's not able to give you an IP address. You get an APIPA address like that, okay? Because sometimes I see they're configuring the server or trying to connect the client to the server, and they get an APIPA address, and they're like, why is it not talking? Well, it's not a private IP address. It's not part of the network yet. So when you see this, it's not part of the network, okay? All right, we can use virtual IP address, and it can use network address translation to convert that back. This is just a way that we can use software to simulate network connection. So when you use your virtual machine, right? Today on your virtual machine, if you look in the network setting of your virtual machine, it's gonna say NAT, right? It uses a virtual IP to connect you to your physical network here at RCCD, even though you're on a virtual machine, okay? Okay, unicast, broadcast, and multicast are here. And then the ports information we just went over right here. We're gonna do a little bit of Wireshark today. So, well-known ports 0 through 1023. And for most of you who are in cybersecurity, my advice for you, know your ports. That's your key. Know the services that tie to the ports, because all scanner is gonna spit out port numbers and you have to know them by heart. Okay, starting with networking class all the way to all the security classes. We're gonna keep repeating the common ports until you know, but when you study for certification, you must know. And when you practice, you must know. Okay? All right, register ports. That's the dynamic ports, like I mentioned before, it's in the higher range, you see? So when you scan and this spits out, you know that it's using dynamic ports. Okay? I put a link here for you. And then the next part is a socket. This is made up of 3 things: an IP address, a port number, and the protocol that's used. Usually it falls under TCP or UDP. So socket is used to send data from one system to the next, and also application. And you see this on development end and also on networking end. Okay. So it's always going to be made of these 3 components to create a socket. So whenever that you hear the term socket, or you see some kind of socket information on the report, it examine the IP address, the port number, and the protocol that's tied to that service. Okay. Okay, so I talk about the components of the socket, which is the answer for 21. IP address, port number of the application, and the protocol that's used under TCP or UDP. And then for 22, why is boot key important in a network? Because routers need it. So that way it will allow DHCP requests to be passed through the router to another segment. And you see this with remote access for workers who are working from home. They would authenticate into, let's say, their employee portal, and that passes through the firewall. But in order to pass through the firewall, it needs to get to the router and then bring them into, right, the private network, so that way they can access the files, the applications that they need when they're working remotely. So routers, it's gonna need boot P, so that way it can get the server to give an IP address to that remote access system. When I remote access into, right, even though I'm from another network, let's say I'm working in Singapore and I'm connecting to New York, I'm still gonna, when I authenticate and VPN brought me in, it's gonna see my system as still part of that network. And that's the whole point in creating virtual private network, tying it back to remote access servers, so that way you incorporating that remote access system as part of your private network. Once they authenticate and they got the security credential or a token that they need after they input their username and password or biometrics or whatever it is, right? So ultimately, the router's job is to bring that traffic in and get the DHCP server to give the client system that's requesting an IP address of that private network. Okay? Okay, so the domains that you see, .com, .net, .io, right? It needs a DNS. And they're often, people lump web server, yes. When you're connecting to, let's say, google.com, you are communicating with the web server, but ultimately the web server, its job is to serve you that web page, the web content. But the DNS is the one that's going to resolve the name to the IP address. So google.com, Google is assigned a public IP and it's tied to Google name. So you guys hear about registering the domain? That's really what it is, right? Put your domain name on the list. It's tied to an IP address. It's kind of like you register to that resident. Okay, your name, you bought a house and you register your house. So your name is tied to that house. So DNS, its job is to get the fully qualified domain name and the URL that you see, right? And tie that to an IP address. So that's a forward lookup. So when you type in google.com, it's really an IP address for that domain in the back, but the DNS, its job is to convert that. That's all its job. So web server is always tied with the DNS because most people don't go around and type 8.8.8.8. That's the default Google IP. I think they changed that now, but there are others because they own multiple sets. Okay, we don't go around and say, hey, visit 12.4.68. Imagine if we are like that, right? We're not. I guess, I don't know. I can't speak for the future, but down the line, we might be very close to our system, I guess. Okay. Then when you install DNS and you see this next time, when we do the lab, you're going to also have a server role that's going to be WINS. And it stands for Windows Internet Naming Service. This is used for the old school legacy system that only recognized by names, right? Because back in the day, we network system by name instead of addresses. So the NetBIOS name, and it uses this to match the system names to the IP. Like, you know, server XYBZ4 to the IP address 10.0.0.118, for example. Okay. So often that you would see by default when we install this role, it's going to ask us to install this. So that way it can tie a physical system name to an IP address for that system on the network. So I put down some steps for you here, right, for configuring. I think we spent a little bit of time on this in our last lab. But you can configure your IP address manually, which we are going to be doing today on Linux, right? So I'm going to demo a little bit of this, I guess. So to kind of review, we did control panel last time, right? Or you can use settings. You only looked at the IP address information, but you didn't manually change anything. But I would go to control panel for Windows, and then you can go to you can go to your network and internet, and then just go to your adapter. In my case, my laptop doesn't even have an Ethernet, so I use Wi-Fi. And once I go here, I go to its property sheets. And under the property sheets, I have the options to change version 4 or version 6. Normally, we change to version 4 as we talked about that today. Click on that, go to properties. And right now, I'm under dynamic IP address obtaining from the server. But let's say that I want to dedicate my computer to become a print server. I need to make sure that it is my IP address doesn't change ever. Then I would select this option, type in the IP, the subnet mask, and the router. Okay? So when you do the Linux part today, that's what you're going to be doing, is to put a manual IP address. So when we say static IP address, we mean manually inputting the IP address, and it's not obtaining from the server. And static IP address is used for dedicated system, servers, printers, routers, switches, security appliances, anything that doesn't change ever in the network with IP address. We want that to be the same, because imagine if you have a refresh IP address 30 days later, a lot of people are not gonna be able to print or connect to the server. And guess who's gonna lose their job, right? Whoever configured this. So, static IP, we select this option. If you wanna join a network, you select this option and you put in the DNS IP address here and the second DNS here. We'll do some of this down the line. Okay. Employers, they also like to ask this questions. So if you're not getting an internet, you check to see if it's obtaining dynamic IP instead of static IP. You ping, you check IP configurations, and then, ultimately a lot of times when you change things, you have to reboot. This is why we're gonna reboot our Linux machine several times today. I had to rewrite that lab because things changed. I wrote it for Ubuntu and I didn't want to use Ubuntu today. But I want to introduce you to Kali Linux, which is a Debian-based system. So, any question? No? Okay. Let me put this back up. Yeah. Okay, so I'm gonna stop recording, give you guys a little bit of a break, maybe 10 minutes. We'll come back. Even though the lab seems long, you can whip through it pretty quickly. I'll walk you through the steps. We're not using crazy virtual machine today, except for the second part, which we can download, extract, and load. Okay.